So one side of a square ABCD has a length of 18 meters. So apparently I do have a square. I'll just graph a quick draft of the square. It's 18 meters. A certain rectangle whose area is equal to the area of the square ABCD. So because they mentioned the area of the square, I'll just get the area right away before even reading the rest of the question. So to get the area of a square, it's mainly 18 times 18, which is 324. This is the area of a square. While the area of the rectangle that has a width of 6 is equal to that one. Now, what's the area of a rectangle? It's supposed to be length times width. One of them, the width is 6. I do not know, though, the length or the measure of the length. So the area of that rectangle should become 6L. And 6L is supposed to be equal to the area of the square, which is 324. So now I have an equation. I can easily find the value of the length by moving the 6 to the other side by division. So 324 divided by 6, and the answer is 54. The length must be 54 and the width 6, so that this would have the same area as a square with lengths or dimensions 18 on each side. Does that make sense, everyone?
Yes.
Yes. Yes.
Awesome. Matrices. Have we ever mentioned anything about the matrices yet? Not so much, right?
We didn't.
Okay.
In your session.
Yes. So let's quickly kida, I'll just tell you the things that matter about the matrices in the ACT, because not everything is included though. But the things that matter are the following: the addition, the subtraction, and the multiplication. So the addition, or in this case, for example, they want me to find a third matrix called C, where they need me to get 2 multiplied by A minus 3 multiplied by B. This is called scalar multiplication, where you multiply the entire matrix by just one number. So 2A means 2 multiplied by the whole matrix of A. When you multiply a number by a matrix, you just multiply that number by each element inside the matrix. So 2 times 3, which is 6, 2 times 5, 10, negative 4, and 2. That's how I multiply by a scalar. And the same thing should be done on the B, which will get me then 3 times negative 4, negative 12, 3 times 5, 15, 3 times 2, 6, and 3 times 1, 3. And then I'm supposed to subtract these from each other. That would be the longest way, by the way, to do it. In this specific question, the easiest thing to do is that first you need to notice if any of the elements are equal to each other in the choices. Like if you can tell the first element in each of the choices different. So if I just knew the first element, I would know the whole answer. So instead of doing all of these operations on all of those numbers, you can just multiply 2 by the first element here, which will be 6, minus 3 by the first element here, which will become negative 12. 6 minus 12 will become 18. So the only answer that has 18 in the first term is F. That must be the correct answer. Does that make sense, guys?
Yes.
Yes.
Not so much.
Are you gonna say the other rules?
Yes. Now, the other rules are the multiplication. So assume that we need to multiply A times B. This is not actually part of the question. This is just the general application. Let's say we have one like this, negative 2 and 1. This is the first matrix. Now the second matrix is negative 4, 5, 2, and 1. In the multiplication, it's a bit different. We do not multiply this term by this term. It doesn't go this way at all. First of all, you need to understand that the answer will come out as 4 different terms, just like how each of those matrices has 4 different terms. So each of those matrix has 4 different elements, 3, 5, negative 2, and 1. There's an upper left element, upper right element, lower left, and lower right. So in order to get, let's say, this element here, the upper left element, the first matrix is the one responsible for the movement up or down, or sorry, for the places of up or down, while the second matrix is the one responsible for the movement right or left. What do I mean by that? I mean, if you'd like to get the upper left, then you'll take the upper row from the first matrix, multiply it by the first column or the left column in the second matrix. Like it's supposed to become 3 multiplied by negative 4, which is this number multiplied by that one, plus this number multiplied by that one, 5 multiplied by 2. The whole total of this thing should be just one number, and it's put up left. If, for example, I'd like to find this term here, the lower right, then I should take the lower row with the right column here. I should go negative 2 multiplied by 5 plus 1 multiplied by 1. If, for example, I'd like to get this one here, which is the lower left, then I'll take the lower row with the left column. So it should become negative 2 multiplied by negative 4 plus 1 multiplied by 2. Finally, if I need the upper right one, I should take the upper row with the right column. So 3 times 5 plus 5 times 1. Once you calculate all of those, you'll get the new matrix of the multiplication. So negative 12 plus 10 is negative 2. This one will become 15 plus 5, 20. This one will become 8 plus 2, 10. Negative 10 plus 1, negative 9. That is the new matrix, which is the product of A times B. Now, this is a very long procedure, so usually it does not, you would never actually have to go through all of this to figure out the answer. Just like what happened in this question. We did not actually have to go through doing all of the numbers in the matrix to find the answer. We could have just got the answer by the first element in the matrix. Same thing should happen here. The choices should guide you, because you'll find that, let's say, this negative 2 is not repeated again. It was not available in all choices. So all what you need to do is just to be able to find the upper right corner, or to be able to find the upper left corner, or the lower left, and so on. Does that make sense, or am I talking gibberish?
It makes sense.
Okay, so again, please try to understand. Try not to memorize the rules about this, and it's column by row and so on. Try to understand how it works. If I need the upper right, I'll take the first row with the right column. If I need lower left, then I'll take lower row with left column. Because that should make things much easier for you to do it, and more understandable, and easier to select the right choice and so on. So that's it regarding the matrix part in this. Now if we go for P7. P7 has too many different theories and not theories, sorry, too many different topics and various types of questions, but they're all important. One of them, which is this one, it's actually a pretty easy question if you know how to use your calculator the right way. If not, then it's still easy, it's just long. So I want to ask you guys, how would you do it first? So if you yes,
I calculated all the seconds.
Okay.
And divided
by
5.
Okay,
So
it got you what? That got you the average of what?
11. It got me to B.
Okay, so you just averaged the seconds without averaging the minutes, or did you transfer them all to seconds, for example?
All the seconds. I just made 2 minutes is 120 seconds, and I just write 220 plus 13, 60 plus 49, 220 plus 27.
Perfect. Okay, so you had to change them all to seconds first so that you can understand how this works, and then you calculated them, huh? And that's okay. What they're asking me here to find is the average time was how many seconds less than whatsoever. If they need to know how many more or how many less or how much bigger, then I'll do something minus something. Apparently, I'll get the average of the experimental group and the average of the control group and subtract them from each other, or just subtract them by each other. So let's see the average. How do I get the average? One way is to do what Alim just did, which is mainly change everything to seconds. Another way is to actually use the calculator. If you go on your calculator and just please hold your calculator square with me, and I'll tell you which button to click on. You know the fraction button, the one that has A over B? Can you all see it now? The one that has A over B on your calculators. I know you're using your scientific calculators, but it should be somewhere here.
Yes.
So the A over B, the fraction one, right under it and then to the right. So the one below the fraction and then the one to the right. It has like circle and then dashes in it. Can you see this one?
Yes.
Okay. If you wrote 1 and then click on this button that I told you about, and then click 46 and then again click on the button. For the calculator now, it understands this as 1 hour and 46 minutes. Okay. So you can add all of those together as hours and minutes and divide them by 5, and it would get you the answer in hours and minutes as they are, without actually having to transfer them all to seconds. Does this make sense?
Yes.
So on your calculator, if you just clicked on 1 and then this symbol that I told you about, it should go like this, and then 46, and then you click again on the symbol, it should go like this. Plus 2 symbol, and then 2 again symbol, plus 2 this, 20 this, 1 that, 51 this, 1 that, and 41 this. If you added all of those and then divide them by 5, it will get you the answer again in minutes and seconds. Just get this average and get that average and subtract them from each other. So I'll do that with you now. It's 1 and 56. This is the average. So this is of the experimental group. I just need to do the same for the control group now. Two. I did something wrong. Oh, I got it. Just give me 1 second. I'm sorry. L2 should come as 2 and 7. Now again subtract using the same symbols, 2 dash 7 dash minus 1 dash 56 dash, and it should get you 11 seconds right away. So you just, the only thing is you can do it without the way that I just explained, but it just decreases a bit of time because you have your calculator with you. So instead of actually multiplying each minute by 60 and then adding them all together, just start adding them right away with the symbols and it would get you the answer right away. Does that make sense to everyone or not so much?
It makes sense.
Okay. Sorry. Now, let's check 32. In United States, phone numbers begin with a 3-digit area code. This is a very important type of question, so please don't focus with it. 3-digit area code. Now, there are restrictions on some of the digits, but in the future, as more and more area codes are needed, the restrictions may need to be lifted. If and when there are no restrictions, each of the 3 digits can be any integer from 0 through 9. How many area codes could be possible? So I have, this is how we think about those. Whenever I need to count things like those, different choices or different possible outcomes, we do something, we use something called fundamental counting principle. How many spaces do we have? We have 3 digits. So these are 3 spaces, and that's how I write them down. In the first space, how many possible choice can we put here? So you're not going to put the actual choice, you're just going to put how many possible answers could be there. How many possible numbers can I put here? Apparently, if I have from 0 to 9, these are 10 numbers. The 0, and then 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are a total of 10 possible choices. And then there are no restrictions, like I can repeat again the same number that I use here, I can use it again here. So the number of possible options to pick from are still the same, from 0 to 9, which are 10, and then again 10. All what you need to do is to multiply these by each other. That should get you the number of possible outcomes, that is 300, 1000, I'm sorry. The number of possible outcomes that could be there using these number of options. For example, in another case, if they said that the first number cannot be a 0, then I'll have only 9 possible options to pick from. And if they said that I cannot repeat the same number again, this one will be 9 as well again, because if I selected 1 here, and then now I have 10 to pick from, 1 was already chosen, the choices have decreased by 1. And then if I selected 1 here and 1 there, then the choices here now have decreased by 2. If I multiply those, that would get me the number of possible outcomes that does not start with a 0. Does this make sense, everyone?
May you repeat that?
Yes, of course I can. So imagine there were some restrictions. Let's say that the first number cannot be a 0. So how many possible digits can I pick from? It's instead from 0 to 9, it's now from 1 to 9. How many possible ones? There are 9 choices. Now, what if I said that I cannot repeat a number? Like if I chose 1 here, I can't use it again here. So now, when you look at the second term, how many possible digits should I pick from? It's from 0 to 9, but one of them could have been picked in the first choice, huh?
Yes.
So now I still have 9 choices available. It was from 0 to 9, which were 10 choices, and one of them was used already in the previous one, so now 9 choices available. Now we've used one term here and one term there. How many possible options can I put here now from 0 to 9? Only 8 options. Does that make sense?
Okay, Mr.
If you multiply them by each other, that would get you the number of possible, the possible order of numbers that apply the same conditions, where 0 is not in the first term and there are no repeated numbers at all. Does that make sense?
Yes.
Awesome. This one is honestly very easy. So you're given a function and so on, but they're asking you how many x-intercepts does the graph have between 0 and 1, and it's not equal to 0 and it's not equals to 1. And you can see here as well, this is an open circle as well. So the 1 is not included and the 0 is not included. So I can't count these as x-intercepts. All the rest are x-intercepts though. So this is an x1, 2, 3, 4, 5, 6, and 7. This is your answer. How many x-intercepts are there? 7. I can't count this one and I can't count this one because the inequality that they used here, it's not less than or equal, it's less than only. Is that easy?
Yes.
Yes, it's easy.
So they're saying here if x and this whole thing are positive integers, what is the least possible value of x? So x needs to be an integer. So when you look at the choices, they're all integers. It could be any of them. But it's also this needs to be an integer. So you just need to put it on a calculator, make sure that the number that you pick is divisible by 3 and 7 and 9. You need to make sure that the number that I'll substitute here, when I divide it by 3, it would come out as an integer. When I divide it by 7, integer. When I divide it by 9, integer. So the 21 is divisible by 3, it's divisible by 7, but it's not divisible by 9. 27 is divisible by 3, but it's not divisible by 7, but it is divisible by 9. 36 is divisible by 3, it's not divisible by 7, it is divisible by 9. 63 is divisible by 3, and it's divisible by 7, and it's divisible by 9. صح? Or not? Actually, no, I honestly can't think clearly. Yeah.
Yes, Mr. 63
Yes.
is good.
That's weird. Yes. So, you can just try them out without thinking at all. Just when you see an x there, substitute, or you can just think about it for a second and think of a number that's divisible by the 3 of them, and whatever is divisible is not divisible by any of them, just remove. Now P8. Geometry, and it's a parallelogram. We're given a few angles and sides. You're asked to find the measure of angle BAD. Given that DC is equals to a specific value of n, you're asked to find that as well. And then on the same shape, they just told you suddenly, suppose that this is an XY plane, and start trying to get the distances and so on. Okay, so first of all, you need the measure of angle BAD. Now, in any parallelogram, the opposite sides are equal to each other. Sorry, opposite sides and the opposite angles, by the way. So this angle is equals to this whole angle. Also, the adjacent angles are supplementary, which means plus each other is equal to 180. So if I need the measure of angle BAD, it means I need this part here, this region entirely. And since this is a parallelogram, then the blue part along with this red part, the 71 and the 42, should all together be equals to 180. All what we need to do is do 180 minus the 71 and minus the 42. 113. So 67 is the answer. That's for the first part, 35. Any questions there?
Nope.
When you check 36, you're given that DC is equivalent to a specific expression, 1/3n plus 7. Where is DC? This is DC. Apparently DC, since this is a parallelogram, is definitely equals to this as well, AB, which is 2 over 3n minus 5. You ask to find the value of n, so I can just easily say that 1 over 3n plus 7 must be equals to 2 over 3n minus 5, because this is a parallelogram and the opposite sides are equal to each other. So now move the n's towards each other and move the numbers to the other side. I'll have 7 plus 5, which is 12, equals to 2 over 3n minus 1 over 3n, which is mainly 1 over 3n. I just need now to move the 3 to the other side, and I'll have the value of n as equals to 36. That's k. Is this clear, everyone?
Yes.
Yes.
Awesome. Awesome. Now this one is a very important one because we did not do any of those yet. So you're given that A and C are located at the point 2 and 10, 30 and 3. So let's go back to the shape. Here's point A and here's point C. This is 30 and 10. Sorry, 2 and 10, 30 and 3. They want the coordinates of point E. Now, point E is the intersection between the diagonals of a parallelogram. Now, generally, the diagonals of the parallelogram bisect each other. They split each other into two equal measures. So apparently point E is definitely a midpoint between both points. So all what I need now is to find the midpoint between these 2 points. And to find the midpoints between any things in the world, we just need to add them to each other and divide them by 2. We've mentioned this earlier as well. And since this is a point that has x and y, so I'll add the x's to each other and divide them by 2, then add the y's to each other and divide them by 2. That should get me the new midpoint. This one will become 32 over 2, which is 16. That one will become 13 over 2, which is 7.5, or just 13 over 2 as it is, so E is the correct answer. Is this clear, everyone?
Yes.
This is awesome. Which of the following triangles is congruent to ABE? It's still honestly on the same shape, by the way. So on the same shape, they're asking me which is congruent to ABE. ABE is this triangle here. So which is equivalently, which has the same measures and everything. Now, in order to know congruent, it means they should share the same angles. If you can tell, this angle is definitely equals to this one because of what we call vertically opposite angles, because they're just across each other. Also, because of the parallel lines, this angle is definitely equals to that one. That's the Z shape that we discussed earlier. These are called alternate interior angles. There are also the other two, which is this one and that one, this one and that one are equal to each other. So apparently these are the two triangles that are congruent to each other. Also, this side and that side are equal. This side and that side are equal. This side and that one is equal. So that's congruent to ABE is EDC or CDE, this one. This one is clear, right?
Yes.
Yes.
Mm-hmm. Which of the following expressions is equal to this? And you have two brackets that are multiplied by each other. They have radicals, they have A and B and so on. Now, when we multiply two brackets, in any case, we just distribute. And that's what we're going to do. So A times A would become just A squared. Now, I want you to notice, let's continue. A times A is A squared, and then A times this is negative 2A root B. And then root B times A is positive A root B. Root B times this is negative 2. Now root B times root B, the roots will cross each other and the remaining is just a B without a root anymore. When we look at those, they share the same like terms, like they have the same expressions, the same terms, the same variables, these two. So I can actually add them. I leave the A squared as it is, but I'll just add the negative 2 plus the 1, which will become negative 1 A root B minus 2B. So the answer right away is B. We all good for this one?
Yes.
Awesome. This one is pretty interesting.
I couldn't solve this, I think.
Okay. So what did you understand?
I find 5.4 the closer and 4, and it was true, but I'm not sure about it.
Okay, so the
answer was true, but I didn't find 4 directly.
Never mind the answer. I just want you to tell me, what did you understand? Like, what's this story all about?
There is 2 circles, and there's a train go around them.
Okay.
And it goes 25 feet per minute. So how many minutes should it spend to correct the A chip?
Okay, so to go all around this shape.
So we need to calculate the circumference for 2 of the.
Yes.
2 of them.
Yes, exactly.
It's 15 times pi times 2.
No, yes, but let me first ask you a couple of things. So what's the circumference? You said? What's the rule of the circumference?
Pi times
2
pi times r.
Yes. So what's 2 times r? Isn't this the diameter? 2 radii is the diameter, right? So d pi, this is considered the circumference of a circle. So the circumference of a circle is d pi. Now here's what we're going to do. The circumference of this first circle is 30 pi then. The circumference of the second circle is 50 pi, correct?
Yes.
So a total of 80 pi, that's the length of the whole trail or railroad, correct?
Yes.
Good. We need to transfer that and get it actually as an actual feet. So on a calculator, just multiply 80 times pi. That would get you to 151.3. He's doing 75 feet in 1 minute. So how long would it take him to go to 151 feet, 0.3 in how many minutes? And I'll cross multiply.
It's 3.25.
3.25, correct?
35, yes. 30.
35, okay. So how many minutes to complete the whole thing? To the nearest minute.
It can be 3.
So to the nearest minute, what would it be? Must be 3 because 3.3, this one is less than 5, so this one will stay as it is. The answer is 3. It's H. Does that make sense, everyone? Alim, is it clear now where did the mistake go or where did we go wrong?
Yes.
Awesome. Mehmet and Amina and Busra, are you all okay?
Yes. Yes.
Okay. Of course, the calculator can easily calculate those for you, but it's important best to remember to understand one thing about them. Like you can do this on a calculator easily, but I want you to understand that whenever we have a negative power over a fraction, we can just flip the fraction. So if I have, let's say, a over b all to the power of negative x, and I want to change it to a positive x, I'll just flip the fraction b over a to the power of positive x. So this, for example, is the same as 5 over 4 to the power of positive 3 over 2. I know that may not matter at all. If this question was without a calculator, it would have been actually a hard one. But with a calculator, it's extremely easy. Like without a calculator, if you just want to know, because it may come, for example, with letters rather than numbers, we should put a power, when there's a power over a fraction, we should put the power over both numbers. So it should become 5 power 3 over 2 over 4 power 3 over 2 as well. Now, whenever we have a power as a fraction, it should be switched for the numerator to stay as a power and the denominator to go out as an index to the root. But because we can't write a 2 here, because the index of the root is already 2, we don't write it down. So it's just as the square root of 5 power 8. And this one is considered 5 power 3. This one is considered 4 power 3 under also the square root. Does that make sense, everyone?
Yes.
So this rule of having x power a over b is the same as x to the power of a under the b root is an important rule, okay? That's mainly it. So on a calculator, it should get you the answer right away, and I think the answer is, what is it? Did anyone calculate it actually?
Yes, I think B. It should be B.
Okay. Let me
This 4 power of 3 is 64. 64 square is 8.
Oh. Again, can you see that again? 4 to the power of 3?
3 is 64. 64 square is...
Yeah. It's yes, it's true. You can actually calculate it طبعا mentally actually كمان, and since this is 5 to the power of 3, so the square root of 5 power 2 is just a 5 that goes out, and there will be remaining only 1 5 inside the root. So yes. صح, thank you. Give me a second because I just need to switch back to the internet, to the one that's not working. Okay, can you guys all still hear me clearly?
Yes, we can.
Okay, awesome. Now let's move to the logs. Anyone knows anything about the logs? You've taken it in school, I think, صح?
Yes, we took it.
So you do understand. So you do understand the basic of it, or do you want me to quickly remind you? Because it's very basic in
A reminder is good.
So mainly the idea of a log is that it finds the power. So for example, if I have 2 to the power of 3, what's the answer of that? It's 8. So if I don't know, if I want to know what 2 to the power of what would get me 8, that's where the log comes in handy. Because the log would say it this way. It would say log of base 2, 8 is equals to what? So it would be equals to x. The answer of the log, the result of the log, is the power originally. And the base of the log, this one, is the base that was there originally. While this, again, is the power. Now what's after the log, which is this 8, is originally the answer that was supposed to be there. So in other words, if I have, let's say, x to the power of 3 equals 10, if I need to change that to a logarithmic form, I'd say log with the base of x, the answer 10 is equal to the power of 3. This case is exactly similar. When you have log base x, then something equals to -2, if you want to reverse it, it would go x to the power of -2 equals to this. X to the power of -2 equals to 1 over 25. Now, earlier we said that whenever we have a negative power over something, it should be switched to a positive power by changing it to the denominator or moving its location. So that now can give me the impression that this x squared is definitely equals to the 25. So if x squared is equals to 25, then what's the value of x? It's the square root of 25, which is 5. So the answer is F. Are both ideas clear? The idea of a log and transforming from powers or exponentials to logs, as well as the idea of this question itself, or not so much?
It is, Mr.
Okay, طيب. There's one more thing just to add, the len. The len is the same as log, but with a base of e. E is a constant number on your calculator, just like the pi, for example. It's called the natural base. So this is len is the logarithmic natural base. If I find something that says len is equals to 1000, I can change that to become e to the power of len x, for example, equals 1000. That will be e to the power of 1000 equals x. So len is always, it always has a base of e. And if there's a log without a base, then the base is 10. That's what we call a common log. Points lie on a line which points also lie on the same line. Apparently, when I do have points and we're talking lines, I think of slope right away. So what I'm going to do is the following. I'll use this point along with this one to get the slope, or maybe easier actually to use these two because they have zeros in them to get the slope. So I'll say 0 minus -3 over 6 minus 0. That would get me 3 over 6, which is half. So I have now the slope. And since I have the slope and I have this point here, this is a very significant point. Because whenever x is equals to 0, the y is actually considered the y-intercept. So if I have the slope and I have the y-intercept, I can actually write the equation in the slope-intercept form, and I can say y is equals to half x minus 3. Which of the following points also lie on the line? All what you need to do is to substitute instead of the x, -3, and check if the answer came out as -4 or not. Substitute instead of the x, -1, and check if the answer came out as -4 or not, and so on. So the answer in this case should be half times 4 is 2, 2 minus 3 is -1, it's D. Because if you substituted 4 instead of the x, minus 3, that would come out as 2 minus 3, which is -1, and that's the same as this y here. D is the correct answer. Does this make sense, everyone?
Yes.
Okay. Awesome.
You know, so I just draw the graph and find it. It was much easier. I just forget to do it in that
the rule. Yes, I know. So and that's why, if you remember, when I explained linear equations, I wanted you to link specific things to each other, like the word line and points, slope, right away.
Yes, yes.
So that you don't get on thinking in a different path, on a wider path. Now, there's one more thing I need to tell you also, that there's not a single case so far that I've ever seen in any ACT test or SAT, by the way, where you actually have to graph on an XY axis, ever. So there's always a way to actually figure it out without graphing. Always.
Yes.
Okay. Because the graphing is hardest and it's the most inaccurate calculations, by the way. They're not accurate at all, the graphs. Anyway, so yes, let's check this one. Raya and I don't know how they look for these names. Raya and Sampa start running laps from the same starting line at the same time and in the same direction on a certain indoor track. Ria completes one lap in 16 seconds and Sampath completes the same lap in 28 seconds. Both continue running at the same respective rates and in the same directions for 10 minutes. What is the fewest number of seconds after starting that Ria and Sampath will again be at the starting line at the same time? We just need to look for a number that's divisible by both. The least common factor. These kinds of questions are mainly the least common factor. We need a number of minutes or a number actually of seconds, one of those choices that could be divisible by the 16 seconds, which is the time Ria takes to finish one lap, and is also divisible by the 28 seconds, which is the time the other guy, the Sampath, completes one lap in. So just divide them, 88 divided by 16 on a calculator, and check if the answer is an integer or not. So it came out as 5.5. 88 is not an accurate answer. 112 divided by 16, it came out as 7. So I just need to check 112 divided by 28. And it came out as 4, so it's divisible by both. So yes, 112 is definitely the correct answer. Does that make sense?
Yes.
Okay. I myself, as a teacher, used to get confused so much in those questions. As a teacher, even. And
I did in this.
Yes, and I used to count and start to think. Yeah, exactly. It's like 16 and 16 and 16. So how many times will they meet each other? And then suddenly it just got me. Like I one time actually insisted to do it. So I started putting 16 circles and 28 circles and checking. So in that moment, I figured out like, whoa, this is the division. This is what we're doing. It's division. So I understood by then. Anyway, type 40 now 5. The CFO of the Math King Enterprises estimates that if the company sets a price of C cents for each unit of their new product, then the weekly profit from the selling product will be modeled by this. According to this model, for which of the following values of C will the weekly profit of this project be the largest? So I need the weekly profit to be the largest. Well, apparently they're saying that the product, actually there are more than one way to do this. First of all, to be the largest means that I need the maximum. And since this is a quadratic function, I can tell clearly, then I should be thinking about the maximum of a quadratic function. And whenever I think of the maximum of a quadratic function, I should think of the y of the vertex. That's what we actually explained in quadratic functions. So this is a quadratic function that's written in the form of ax squared plus bx plus c. But in reality, it's missing the c, and the bx is written first, and then the ax squared. So when you look at this, you can identify the a as -4 and the b as 1600. If you need to get the vertex, you should do -b over 2a, which will be here -1600 over 2 times -4. Once you do that on a calculator, it will come out as 200. This is the x coordinate of the vertex. Now, I do not want the actual profit, the highest profit that they will get. I need to know the c, which is the x coordinate when they were with the highest profit. So 200 itself is the right answer. D is the right answer. I know this may sound confusing, so please ask. And there's another way to do it anyway, but yeah, please ask. No?
I understand it, but I use the other way, just simplifying by the answers to
Like
the question.
Substituting, you mean? Ah, yes.
Yes.
So you're going to put instead of the C 20 and then check which one gets you the biggest answers, huh? Again, this is the same. So you see, this is where the perspectives are different. Like I look at the question, the previous question and this one through what I know, not what they say. So the first question, the previous one, when they said line, I worked, not this one, the one before that, the line one. I worked with what I know about the line, slopes. Instead, you decided to think about what they want me to do. And then again here, you thought about this as what do they want me to do, and try to think about it by common sense, which works, by the way. I'm not saying it's not right. I actually do that. I love that comment. But then I worked with what I know, and because I saw a quadratic function, I thought definitely it's about the vertex, because as I said earlier when we were explaining vertex, the most important thing in the vertex is in the quadratic function is the vertex. So that's what I mean by different perspectives. When you get stuck, so I like that it's working for you so far. Your method is working for you, and I love it because that's what I do usually. Because when I get stuck, try the other bad perspective where you're like, okay, what do I know about this, and put it down and start to substitute. Okay.
Okay, Mister.
And also when it takes so much time, Alim, when you find that you're taking longer than expected, then stop and retry the other method that we were talking about. Okay. Now P10 and 11. Given that these are consecutive integers such that is one bigger than the others, which one has the greatest value? So the whole idea here is actually they need to check your understanding about fractions in general. So in a fraction, the bigger the denominator and the smaller the numerator, the smaller the overall fraction. So for example, if I'm talking about 2 and 4, that's a half. But if I'm talking 2 and I started to increase the denominator, let's say it became 7, that's a smaller fraction. 2 out of 100, that's an even smaller fraction. So the bigger the denominator, the smaller the overall result. And the bigger the numerator, the bigger the overall result. So it's as if like the leading thing is the numerator, and that's true. So if I have, for example, 100 divided by 4, or 200 divided by 4, that's getting bigger now. Or 1000 divided by 4, each one of those is getting bigger. So as long as I'm increasing the numerator, the whole number is increasing. So when you look at those and they're asking me which one of those has the greatest value, if I picked a huge number like this one, this is the biggest, and I divided it by the smallest number, that should be the greatest value. So if I add, so when you look at the choices, they're saying A over B, the smaller divided one that's a bit bigger, or B over the one that's a bit bigger. So I can actually try out numbers here. And you can just say like whatsoever numbers, 3, 4, 5, and 6, and try them out. So A over B, that's 4 over 3. Sorry, 3 over 4. And B over C is 4 over 5. And C over D is 5 over 6. And A plus B over BC, this is 3 plus 4 over 4 plus 5. And BC plus CD is 4 plus 5 over 5 plus 6. Try them out on the calculator and check which is the biggest. It should be this one, by the way. Right? No. It should be H.
H.
H, yes, H. Yes, because in general, if I'm increasing both the numerator and the denominator, that does not necessarily mean that the whole number is increasing. So for example, 2 out of 3 and 36 out of 60, 2 out of 3 is actually bigger than 36 out of 60. Yeah, it does not necessarily mean that these are actually the smallest. Or it does not, if I increase the numerator and denominator, it does not necessarily mean that the overall number will increase. It could actually be getting smaller, not bigger. Does that make sense? Or
Yes.
okay. Okay. the ratio of the parameters of 2 to 3 if the okay. The ratio of the parameters of two squares is 2 to 3. If the area of the larger square is 324 feet, what is the length in feet of the side of the smaller square? So first of all, when I'm given an area of a square, what do I know about an area of a square? That it is side squared. So if I need to know one side of a square, I should just get it by the square root of the area. The square root of 325 is 18. So I know that the side of this square is 18. I have a square right here. This side is 18. So if I needed the parameter of this square, it's 18 plus 18 plus 18 plus 18. So it's 18 times 4. Again, that's the parameter. They said that the parameter of the two squares are the ratio of 2 to 3. And apparently the bigger one, this is the one that I'm working with. That's the bigger one. So the 72 should go under the parameter or the ratio of the bigger circle. This is apparently the smaller one. This is the bigger one. If I need to know the parameter of the smaller circle, this one, I'll just cross multiply. So I'll do 72 times 2 and then divide by 3. That would get me 48. So the parameter of this smaller circle is 48. They need the one side of it. So I should just divide the 48 by 4 because there are 4 equal sides. And then the side would be equals to 12. Please ask about this one because it has too many different things. So please ask.
I just use the 18 as 72. So yes.
As for the 2,
for the ratio.
So you assume that it goes for the smaller one, huh?
Yes.
So it's good you understand now where the problem is, and I think that won't happen again, fellows. Everyone else, I know you have not solved the questions. These questions, that's why I think you're not asking any questions. So that's why I don't like those kinds of sessions where I'm just explaining. So I'm sorry, but I won't be able to do this every time. I have to give you things to solve and then I explain because that's how hopefully you'll have some sort of questions there. So anyway, they're saying what's the set of all integer solutions for this inequality? So that's a normal inequality that's written right there for you. If you need to find the value of x, you should just remove everything around to the x to the other side. But we here have two different sides, so we should move this negative root 5 to both by addition. So I should have here negative 1 plus root 5, and then x, and then 4 plus root 5. Please calculate this on a calculator. That should get you negative 1 plus root 5. It's 1.2. That's 6.2. So the integers that would be between, that applies for the solution set would be between 1.2 or between 2. I can't actually be, I need to be bigger than 1.2, so I can't take the 1. So I'll start from 2 up until the 6 exactly. And the 6 is included because I'm right below the 6.2. So I have choice G as the correct choice. From 2 to 6. Does that make sense, everyone?
Yes.
Yes.
Awesome. This is the one you were asking me about. So let's see how this works.
No, 50. I was asking for.
Okay. So we'll do this one quickly anyway. Wind blowing against a flat surface exerts a maximum force equals to this. S is the area of the surface. V is the wind's velocity. K is a constant. 40 mile per hour wind can exert a maximum of 50. Now, this question is just mainly literally substitutions. Okay. So first of all, you know for a fact that S is the area and V is the velocity. This V here. And they said then that the 40 miles per hour, that's the velocity. Sorry, that's the maximum force. So the whole result, the whole thing is equals to 40. So the KSV squared is equals to 40. No, I'm sorry, I got it right. Sorry, wait. 40 miles per hour, that's the velocity فعلا. So then K and then the S as it is, and instead of the 40, the V, I'll put 40, that's the velocity. Now that can exert a maximum force of 50. So that is supposed to be equals to 50 on a 1 square foot flat surface. So the surface area, which is S, is supposed to be 1. Then they're asking what is the maximum force that an 80 mile per hour wind can exert on a 2 square foot flat surface. And what I did here should just get me the value of K. And they told me here that K is a constant. So if I have the value of K, I can just now substitute it here, and I can substitute whatever they want and find later on. So I'll just need to move the 40 squared to the other side by division. So then K is supposed to be equals to 50 divided 40 squared. That's the K. So the actual equation is now 50 divided by 40 squared. And then they said that the surface area now will become 2. The velocity now will become 80. So that's 80 to the power of 2. Calculate this on a calculator and it should get you the answer right away.
400, I think.
Okay. But everyone else, is this okay ولا ايه? Everyone, is this okay?
Yes.
So it's just mainly substituting to find the value of K first. And then once we found the value of K, we were able to have an expression that could be used to calculate anything I want later on. 50 is the one you were asking me about. So let's see. Roger will pour concrete to make a sidewalk with the dimensions of this shown in the figure below. He will pour into the concrete to a depth of 4 inches. 1 bag of concrete mix makes 0.6 cubic feet of concrete. What's the least whole number of bags of concrete mix that Roger needs in order to make the sidewalk? Okay. So this is the sidewalk, but this is not just it. This is like a picture of you looking at the sidewalk from above. But then this will have a thickness of 4 inches, which means it's like a bit thicker than you think. It's a 3D shape. And that thickness will be 4 inches. Okay? And remember that everything is in feet. The dimensions that you have now are in feet. The only thing that's in inches is this. Now, generally, they'll always give you the rate of change from inches to feet. From 1 foot to 12 inches. 1 foot is equals to 12 inches. So they'll give you that rate right away in the question in all international tests. So instead of 4 inches, I can say that this is actually 1/3 foot. How did I do that? If this is 4, I'll just cross multiply and I'll get here 4/12, which is mainly 1/3 foot. So the 4 inches is equivalent to 1/3 foot. This is 1/3, this is 1/3, this is 1/3, and this is 1/3, and this is 1/3. Now I just need to get the volume. The volume of the whole shape is yes.
I made a mistake while the inches and feet. I didn't check this.
I'm sorry, can you say that again?
I didn't check the feet and inches. I just write it 4. That was the mistake.
So that was the mistake. Okay, that's fine. So we can figure this out already now. So then how do I get the volume? It's the area of the base multiplied by the height, right? So I'll get the area of this shape, which is mainly 4 times 10. This one is 40, and then here it will become 4 times 16, which is this side here. 4 times 16 is 64. So that's the area of the base will be 104 multiplied by the height, which is 1/3. That should get me the volume of the whole shape. So 104. The volume of the shape is 104/3. Now I'll take 0.6 cubic feet of concrete. That's the one bag. And one bag will cover 0.6. So the 104/3 will take how many bags? And I'll cross multiply. So I'll do 104/3 divided by 0.6. That's 57.7 bags, which is then 58 bags total. Please ask. Nothing? Do you understand? How? Is it confusing type?
Not just the transformation of the inches and foot. You need to read carefully.
Yes, and as I told you, if this is an international test, the one that you will test, it should not have, or it should give you clearly the rate of change somewhere, especially from feet to inches, because only the states use feet and inches. In ours, it will give you centimeters and meters and so on. Does that make sense?
Yes, yes.
Awesome. So, if I may ask you please to fill in the exit tickets, and I'll upload this for you. If you don't mind, I'll upload another homework for you, another test for you. Please do it as a homework. Actually, here's the thing. I'll upload one for you as a homework, that's a PDF, and next class we're not going to solve that. We're going to solve a new one in class, 5 questions each and so on, okay? And then the class after will collect the homeworks. Does that make sense? So one class we're working on a test, the other class we're explaining different questions that you have problems with. Okay, kid?
Okay, Mr.
Okay, awesome. Done deal. Thank you guys so much. If you have any questions, please let me know now. I'm staying until I'm done with the uploads and everything.